Hello. Welcome to the video lesson for the weekend. In this lesson, we're going to learn how to calculate percent composition, which we kind of already did, and then finding empirical formulas. Both these things you learned in Honors Chem. The molecular formula piece you did not. And we're actually going to save that for Monday because it's a little bit more involved in the math. Not that much more involved, but I feel like it would be a good idea to save it until Monday. So today we're going to learn how to calculate percent composition, which I think we've already sort of done. And then using percent composition, you can find something known as the empirical formula. So if we have this compound here, and we need to determine the percent composition of oxygen, basically saying how much of it is oxygen. So the first thing you have to do is find the total mass of the compound. And that's basically finding the molar mass. So you take the mass of carbon and multiply it by 3, the mass of hydrogen, multiply it by 6, and the mass of oxygen and multiply it by 2. And when you do that, which I pre-did, you get this lovely number here. Okay? And it wants the percent composition by oxygen. This is the total mass here. And there are 2 oxygens, and you hopefully memorized by now that each one weighs 16, so that's 32. And that goes on top of the fraction. And then we're going to multiply this by 100 to turn it into a percent. And we end up getting 43.2%. Don't worry so much about the sig figs in this lesson. Sig figs are really not important for what we're going to be doing here. These questions will usually be multiple choice. So we're not going to really worry much about sig figs. We did that in honors chemistry. It was like our day lesson of finding the percent composition of an element in a compound. So basically, to summarize, you find the total mass of the compound, which is here, and then you find the mass due to oxygen in the compound. Here, there are 2 oxygens, each one weighs 16, so that's 32. We do 32 divided by the total, multiply by 100 to get it into a percentage, and there's our answer. Now, we're going to do something a little bit harder, but you'll be happy to hear that this lesson is much easier than like the stoichiometry stuff that you've been doing, because there's no way to really word it in a tricky way. So you'll probably be happy. So we're going to now learn how to write an empirical formula if you're given a percent composition, but first we need to know what an empirical formula is. Okay. So an empirical formula is a formula in which the numbers are in the smallest whole number ratio. So if we look at this question here, it's asking which one is an empirical formula, and we're going to look at each one. So if we look at this is actually glucose, and this is not an empirical formula. The reason why this is not an empirical formula is all these numbers are divisible by a number. Like you could divide them all by 6 and get a smaller whole number ratio. The empirical formula for glucose would be C1, which we don't write, but I'll write it there, H2, O1, because all of those numbers in the formula are divisible by 6. So this is not an empirical formula. Either is this one, because all the little subscripts in the number are divisible by 2. So this is not an empirical formula. Nor is this one here, because all of those little subscripts there are also divisible by 2. The empirical formula for that one, since we can divide both of those by 2, would be CH3. This, however, is already an empirical formula. It's as simple as it can't be written any simpler. Nothing can go into 1 and 4 evenly, so this here is the smallest whole number ratio that you can have. So these questions here are asking us to write an empirical formula from the formula given. And this formula, actually, these are molecular formulas. And from them we're going to write empirical formulas by simplifying the subscripts. So if we look at the subscripts here, the subscripts are 4, 6, and 4. And what can go into 4, 6, and 4 evenly? Well, that's 2. So for carbon, since it's 4 divided by 2 is 2. 6, it's 6 for hydrogen, so we're dividing this by 2, which is 3. And then oxygen, there's 4 of them divided by 2 is 2. And then that is the empirical formula for that formula. Same thing here. All of those numbers there are divisible by 2. So we divide this by 2, C7. This by 2, H5, and this by 2, O2. And that is our empirical formula. Again, this is an empirical formula because these can't be reduced anymore. Nothing can be divided into them evenly. So they can also present these questions to you using pictures. And they're saying that they have this diagram that was represented by a decomposition of a compound. Okay? And the blue spheres are nitrogen, and the red spheres are oxygen. Okay? Now remember, when you do a chemical reaction, the number of atoms have to stay the same. Okay, so even though after the decomposition, the number of atoms that you started with is the same. So to do this, to find an empirical formula of the compound that decomposed, we have to count the atoms. So remember, nitrogen atoms are blue. So if we look at the nitrogen atoms there, and I know you don't have color, so I apologize. 1, 2, 3, 4, 5, 6 nitrogen atoms. And then our oxygen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So our formula is N6O12, but when we look, those are to get the empirical formula. Both of those are divisible by 6, so we get NO2, which makes it choice 3. This here is a similar type of problem. And so in this mixture here, we have a mixture of carbon dioxide and water from a combustion reaction. And a hydrocarbon, by the way, is any molecule that contains just carbon and hydrogen. So what this is saying is we had some sort of hydrocarbon. We don't know what the X is. We reacted with oxygen, and we produced carbon dioxide and water, okay, which is what happens in any combustion reaction, okay? And we want to know the original formula, okay, or the empirical formula for the original compound. Now, just so you know, in general, carbon is black. Like when we're representing carbon, we represent it as black. Hydrogen is white, and oxygen is red. So we're just going to do the same thing. Remember, this doesn't have any oxygens. You don't have to worry about the oxygens here. The oxygens are coming from here. So let's count the carbons. And we have 1, 2, 3, 4 carbons. And let's count the hydrogens, and which are harder to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So our formula, which is our molecular formula, is C4H16. Okay, but then, as you know, both of those are divisible by both 4 and 2. 4 is the bigger one, so we're going to do that. So if you divide this by 4, we get C, or 1. And then this divided by 4 is 4. So that is our empirical formula. These are both divisible by 4. So our answer is that. Okay. I probably will be able to make it, but I'm going to upload this video and do the other video, the next couple of problems in a separate video, just so I don't run out of time.